Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through the factor and remainder theorem. So both of these have to do with polynomial division, when we take a polynomial fx and divide it by a linear factor x minus a. So the remainder theorem says when you perform that division, this divided by this, the remainder will be equal to f of a. So as a consequence of this, x minus a is a factor of fx if and only if the remainder is equal to 0. We'll explain a bit more what that means in a second, but let's just go through this example first. So calculate the remainder when this polynomial is divided first by x minus 3 and second by x plus 2. So the remainder when fx is divided by x minus 3 is just f of 3. All I do is take the polynomial and substitute x for 3. So putting that in our calculator, we actually get 0. What that means is x minus 3 is a factor of this. So what that actually means in practice is I can take x minus 3, I can times it by some polynomial to get f of x. And that's what a factor means. It means it goes evenly into the polynomial. Or if you like, when I divide this by this, there is no remainder. So that's what it means if something is a factor. Now let's calculate the remainder when fx is divided by x plus 2. So note you always insert the opposite. So I'm not going to do f of 2, I'm going to do f of negative 2. So putting this in our calculator, we get negative 30. So because we didn't get 0 as our remainder, x plus 2 is not a factor of fx. So this means I'm actually not going to be able to find a polynomial that I can multiply by x plus 2 to get fx exactly. What I will be able to find, though, is a polynomial. When I multiply by x plus 2, it will give me these three terms correct, but it will get the last one wrong. In fact, if I find such a polynomial, it will give me plus 42. So that's why I need the negative 30 here, where I have a remainder of negative 30. So it's not a factor, but I can find a polynomial that multiplies by x plus 2 so that when I subtract 30, I get fx. All right, let's look at a slightly harder question. So we're going to find the values of a and b if this polynomial has x minus 4 as a factor, and this polynomial, when divided by x plus 1, gives a remainder of 25. So because we're finding two unknowns at the same time, you should straight away think simultaneous equations. We will get one equation from x minus 4 being a factor and one equation from x plus 1 giving a remainder of 25. So since x minus 4 is a factor, what that means is f of 4 must be equal to 0. That's the factor theorem. And the remainder theorem says if you divide by x plus 1 and get a remainder of 25, f of negative 1 must equal 25. So substituting x for 4 and fx for 0, I get this equation here. So just making it a little easier to work with, I get negative 96 equals 16a plus 4b. That is my first equation. So substituting x for negative 1 into this equation and fx for 25, I get this equation here. So that gives me that negative 6 equals a minus b. So I'm going to solve this equation and this equation simultaneously. Let's times the bottom equation by 4, so the coefficient of b is the same in both equations. So this was my first equation. This is the second equation after it's been multiplied by 4. So adding together the two equations, I get 20a equals negative 120, or a is negative 6. So if a is negative 6 and I put it into this equation, I get b equals 0. And that's all the question asked me to do, so I'm done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.